of these food additives. We can assess the safety of the food additives. We can do toxicity profile test. Are they toxic to the body? These are the kind of work we can do. We can also do a work on nutraceutical, whereby I have a food like opa or aki or coconut. I can do a study on nutraceutical to see how this our opa, even if it's serving as nutrient, it can also be medicinal. In fact, I'm currently working on that area, and we are working on this akinokwa we buy on in our bus stops. We want to see if that ake can reduce diabetes. So meanwhile, we can be eating ake as a food, and it's helping to cure our diabetes. We can do such work in food chemistry. Mycotoxin receptor binding. Our flavors. We can assess the effect of these flavors on olfactory lobes, on our respiratory systems. These are different areas we can do on food chemistry. For those who are in the area of agricultural chemistry, we can use it and develop pesticides. 2 months ago, I was privileged to present a paper at IMSU. In that paper, I presented a work on developing a novel insecticide. If you notice that most of the insecticide we are using, if you spray it here, you don't stay there. You have to go out and come back in 30 minutes time or 1 hour time. So there is a problem. So I used computational chemistry packages and developed a novel insecticide from ginger and garlic. So we can do such a work. We can develop herbicide using computational modeling. We can do soil microbial enzymes. Last month, I did a work on carbon capture. The work was similar to the one we know. This is our nitrogen capture, like nitrogen fixing bacteria. We have to develop a bacteria that can fix carbon dioxide in the roots of our plants. You know that plant needs carbon dioxide. They make use of carbon dioxide, and we have them in the air. So we have to do a work on, can we develop some microorganisms that will help trap this carbon dioxide in the air and fix it into the roots of the plant. I think we presented that work will be presented in Ghana. We did the work last month. We will be presenting that work in Ghana. So that is the area of agricultural chemistry. I've already mentioned pesticide. Plant growth. You can model a fertilizer that can support plant growth. Currently, I'm collaborating with one of the big masquerade in Anambra State University. We are working on a nano fertilizer at Uli that will support plant growth. These are different areas we can apply computational chemistry. For those who are in the area of analytical chemistry, you can use it and develop biosensor, ligand-based assay, surface binding prediction. We can use it to interpret spectral analysis. We can use it to interpret GCMS spectrums. We can use it to interpret mass spec spectrums, NMR spectrums, and other spectrums. For those who are in the area of biochemistry, we can use it for enzyme substrate inhibition docking. We can see the ability of an enzyme to inhibit a substrate or to promote the substrate. We can use it in protein ligand interaction. How a ligand can interact with a protein. This protein can be a disease target. We can use it in drug design. In fact, one of the most application is in drug design. We use it in metabolic pathway simulation. We can use it to simulate glucose pathway, amino acid decarboxylation pathway. so many pathways you can model with computational chemistry. In fact, one of them is called KEGG. Some of you must have heard about KEGG pathway and gene ontology. These pathways can be done using computational chemistry. In the area of physical chemistry, we can use it in thermodynamics. I've explained that in under MD, when I was discussing molecular dynamics. I think I explained about thermodynamics. We can use it and calculate free energy from DFT, density functional theory. We can calculate free energy, and also in Chem 3D, we can use Chem 3D to calculate free energy. Molecular dynamics, I've explained that. Solvent effects. These are the kind of applications in physical chemistry. When we come to organic chemistry, we can apply it in host-guest complex. What we mean by host-guest complex is similar to a protein interacting with a ligand. When a protein is interacting with a ligand, is what we call host-guest complex. We can use it and develop organocatalysts. We can develop a catalyst. You know, most of the reactions in organic chemistry involves catalyst. You can use these tools and predict what kind of catalyst will be effective in this reaction. We can apply it in natural product interaction. This one is similar to the case, the testimony I shared with us, whereby you have done your chemical characterization, you have your natural product from a plant. You can predict their possible interaction with different targets. We can use it in organic pollutant binding analysis. This one is similar to the work done in environmental chemistry. Reaction intermediates. We can use it to do docking of reaction intermediates. For those in the area of analytical chemistry, for those in the area of inorganic chemistry, we can apply it in metal-ligand interaction. In fact, in this area, we can build nanoparticles. Nanoparticle is part of the courses we'll be learning in this 3 months training. We can build metal-ligand interaction, coordination complexes, coordinate compounds. We can develop them, metal-enzyme active site modeling, the binding affinity of metal drugs. There are some drugs that contains metals. We can apply them in organic chemistry. This is my area, medicinal chemistry. In medicinal chemistry, we can use to develop prodrug activation. We can use it in enzyme inhibition. It's applied in ligand targets, mostly in SRA, structure activity relationship, off-target interaction, toxicophore binding studies. You can use it to predict if a compound is toxic to the body. You can use it to predict and design new drugs in the area of medicinal chemistry. There are numerous applications. In the area of pharmaceutical chemistry, we use it in drug formulation. We use it in drug formulation. We use it in pharmacophore docking. You can design new pharmacophore. That is the area of pharmaceutical chemistry. We can use it in control release and control delivery system. for those who are working on draw design. We can use it in that area. We can see if our recipient will interact with our drug. You know, when you have a drug has two parts, the API and the recipient. Most time the recipient you are using, like your binders, your glucose, your fillers, they may interact with the API, which is the active pharmaceutical ingredient. We can use our dotting to see if there could be an interaction. We can see if our drug can target our active site. Let's say you are suffering from malaria and you want to develop a new drug for malaria. We can see if that new drug can target the liver. You know, malaria, the parasite feeds on vitamin A. So you can see if our drug can target the active site. There are many applications. We can apply it in polymer chemistry. We can apply it in industrial chemistry. We can apply it in drink chemistry. There are so many ways. In drink chemistry, we can do waste reduction. You know, Nigeria has a lot of waste. We can use it and convert our waste to wealth. It's part of my research this year. We are converting a lot of waste into useful material. Currently, we are producing electricity from plastic waste. We are currently doing that work. In nanochemistry, we can apply it in nanoparticle, material science, nano design. There are lots of areas we can apply this knowledge. So the knowledge you are going to get in these 3 months is a fully packed knowledge. We can apply it in petrochemistry. Those who wish to work in the oil industry. We will be touching these areas one after the other. You can go more and explore, go more and learn. In material chemistry, we can apply it in absorption mechanism, in surface linear interaction. I was trying to explain to some of us who usually do work on absorption kinetics, removal of heavy metals. We can apply it in computational chemistry. In forensic chemistry, we can apply it in forensic chemistry, where we look at the interaction of our poison and the protein. Let's say we have a poison. We can see how this poison can interact with the body, with some active site in the body. We can use it to detect some toxin. There are vast applications. We can apply it in radiochemistry. We can apply it in radiochemistry. We can apply it in electrochemistry, in photochemistry, geochemistry. There are marine chemistry, atmospheric chemistry, astrochemistry, cosmetic chemistry, veterinary chemistry, chemical ecology, chemical engineering. Is applied everywhere. In fact, it is applied everywhere. We cannot. Biophysical chemistry. In fact, let me tell you. You see, this biophysical chemistry is what my lab is centered on. If you notice, you have been receiving messages from biophychem laboratory. The biophychem laboratory is a biophysical chemistry laboratory. That is that name, biophychem lab. It combines biology, physics, and chemistry. So this is the area we do more in that lab. Protein folding, molecular interaction, docking, and protein ligand structural dynamics. So it's a recent laboratory in Imo State. These are vast applications. There are numerous ways we can apply computational chemistry. So in today's class, what we are actually doing is to open you up on the foundation of computational chemistry. We want to let you see the beauty of this course, and that is what we want to achieve today. So by Thursday we shall be looking at the first hands-on practice. So our hands-on practice will be starting effectively by Thursday. So I will give you an assignment today. The assignment to be sent to your email. I will mail the assignment to you. So by tomorrow morning, just check your mail. You will all get the assignment. So far, have you all been able to install all the software? Have you all been able to install the softwares?
Not yet, too.
Okay.
Not yet.
The only one that might have issues.
But hopefully,
I was trying to ask you the other day, Henry.
Yes.
Can you hear me?
Go ahead.
You know, I had this chem draw on my laptop before now, but I don't know whether this one you sent is similar to laptop. So I was trying to reach you the other day to ask you if it won't be a problem to install the other ChemDraw or to leave the one I have already had in my system.
All right. What we are using is ChemDraw Ultra 12. So if the one you have is not Ultra 12, you can go ahead and install the Ultra 12. It will not disrupt the one you have. It will not alter the one you have. So if the one you have is not Ultra 12, go ahead and install the Ultra 12 so that you have two of them. But what we'll be using is the Ultra 12. So
Okay,
don't check
okay.
if the one already in your system is Ultra 12. All right. So, do you have any question? We have spent 1 hour 33 minutes. So I would like us to wind up, and then
somebody wants to break down this place, so
is there an hour for you?
don't mind that man. Don't just mind him. He's a joker.
Oh my God. So just try your best, install all the software, install the ChemDraw, install the ChemSketch, the Pyres, the OpenBabel, the BioVer Discovery Studios. We shall be using them as time goes
But
on.
you've not sent. But have you sent all? It's only this ChemDraw I saw in my email.
No. In that link, all of them are
Yes.
in the link, right?
Oh, okay.
They are all in the link.
Okay. I'll do that before our next meeting.
Okay, before I round
Okay,
up,
I think what I have in my system is ChemDraw Pro 12.02.
okay,
So it's different from that Ultra.
okay,
Pro
ChemDraw,
12, that's what I have.
yeah, okay, have Pro, you don't have Ultra. The Ultra is higher than
No.
Pro.
Okay.
The Ultra is higher than Pro. So go ahead and install the Ultra.
So that is to say I'm going to uninstall this one because
No, you don't need
I'm
to
battling with space.
uninstall it, but if you wish.
I'm battling with space.
Okay.
I partitioned the laptop, which is affecting my storage.
Okay.
Right.
So you can you can go ahead. So by Thursday we shall be starting with the first course, which is came draw. Shall be starting with came draw. So you already have the module for came draw. You can go to the module and see what we have for that came draw. So we shall be starting with the came draw. I really want to appreciate all of you for staying till this very moment. We thank God for the fair weather and the fair network. We are supposed to be up to 15 here for online class. About 15 students registered for online, while about 10 students registered for physical. But maybe some of them, due to certain conditions, they could not meet up. We wish they would join us on Thursday, but the assignment will be sent to everybody. So we have Tuesday and Thursday. We have Tuesday and Wednesday to tidy up the assignments. By tomorrow morning, this video of this training, of today's training, will also be sent to your mail for preview, so that you can on your own preview the classes. So I want to appreciate you all. Thank you, and God bless you.